assign a think of like a weight to different words based on relevancy, which will enable it to capture long-range dependencies efficiently, right? So now that we've sort of touched on the key concepts, let's talk about the impact that this paper and self-attention has had on machine learning. So self-attention now is being used in a lot of modern AI models. Most notably have been models such as BERT, T5, or GPT, and as well as any other advanced NLP systems. This also helped transform machine translation and text generation as well, which allowed AI to essentially achieve state-of-the-art results. And another thing that the self-attention has helped achieve is that it helped enable breakthroughs in speech recognition, summarization, and chatbot development. So very helpful in ChatGPT to help you cheat on your homework. So now let's talk a little bit more about the transformers and really how does it work. So we just talked, so once again, transformers were introduced in the paper. Attention is all you need, right? And once again, widely used in all the natural language processing tasks, such as machine translation and text generation. So the main structure of a transformer consists of two main components. You have the encoder and the decoder. The encoder you can see on the left side right here, and then the decoder is on the right. So both the encoder and the decoder process sequences in parallel, which is far different from standard RNNs, which process sequentially. And another thing about the transformer is that the model heavily relies on self-attention and positional encoding instead of recurrence like the RNNs. So let's jump into the encoder, right? What does the encoder do and what does it look like? So the encoder stack consists of typically 6 different layers, right? And each layer has about 2 main sublayers. These sublayers are the multi-head self-attention, which will allow the model to focus on different parts of the input sequence simultaneously. And then you have the feed-forward network, which is a fully connected neural network applied to each position. And then also in the encoder, we have something called residual connections, right? And the residual connections and layer normalization helps stabilize the training to produce more accurate results. And then another key note here for encoder is that the input embeddings and positional encoding are added to preserve the word order. So now that we talked about the encoder, let's jump over to the decoder real quick. The decoder is also composed of 6 layers, and it has an additional mass multi-head attention layer to prevent future tokens from being seen during training, which is also known as casual attention. Also, like the encoder, it has a feed-forward network and a layer normalization. So very similar to the encoder. However, though, what separates the decoder from the encoder is that the decoder receives the encoder's outputs via the multi-head attention, which will allow it to incorporate context from the input sequence. And now, if we talk about the final output, right? What happens after the encoder and the decoder process happens, right? The decoder's output goes through something called a linear layer, which is followed by a softmax layer, utilizing the softmax function that we talk about so much. This generates a probability distributions over the vocabulary for the next token prediction. and these outputs are shifted right to ensure that autoregressive processing, which means that each word is essentially generated step by step based on prior words, right? So think adjectives to nouns, for instance. Now I'll pass it off to Nathan to talk about the challenges as well as solutions.
Hello, my name is Nathan Rodriguez-Lin, and I'll be covering a couple slides. So first, I will start with the challenges that we will face and how we will solve them. So as with any project, and our AI project, we are expecting to encounter a few problems along the way. The primary and most relevant hurdle is the amount of coding required for a project like this. Considering that we are creating a chatbot with the ability to mimic different characters, the AI has to read and output text in a provided tone and maintain conversational cohesion. To get over this, we will divide the code into components that we are able to tackle, beginning with standalone pieces such as natural language processing, generating responses, and UI integration. Our team will delve into several AI frameworks and model structures so that we can make the appropriate decision on implementation. And another challenge is our training. Now, deep learning models are computationally demanding, and training an AI on character-specific dialogue means working with huge data sets. Not everybody in the team has access to high-performance machines, so we will have to train our model with the fastest machine that we have access to. Now, moving on to the different phases we have. So we actually have 5 phases that we have made to stay organized and make steady progress. Phase 1 will be identifying the problem. Prior to coding, we need to determine the abilities of the chatbot, its audience, and selling points. This includes research on existing AI chatbot models, overall limitations, and how our method can improve user experience. Phase 2, creating the AI model. Once we know what we want, then we will create the foundational AI model. This is selecting the correct neural network architecture, most likely a transformer-based one, making a training environment, and adding the needed libraries such as TensorFlow. Then we will move on to phase 3, gathering data and prepping it for training. Now our chatbot must be trained from authentic dialogue samples in order to accurately impersonate characters. We will collect proper information from interviews, media releases, and maybe even other media, and then pre-process them, filtering out errors and improving model performance. Then we will move on to testing. At first-time training, we will carry out various accuracy, consistency, and operation tests. We will optimize responses, tune hyperparameters, and check for bugs in order to have our chatbot perform according to our desired quality. And then finally, phase 5, deployment. Once the chatbot is in an operational phase, we will focus on deployment. That includes pairing the AI with a user-friendly interface, hosting provisions, and user access so they can interact with it seamlessly. Our chatbot project is more than just building AI. It's about creating a fun and interactive experience. By using advanced machine learning and character analysis, we want to make conversations feel natural and engaging. While there will be some challenges, our teamwork and structured approach will help us overcome them.